Hey, this is my presentation for CS 490, the Big Data course. For our group project, we are examining energy usage using a data set using weather and energy usage from 5 different cities in Spain. So for my portion, I worked on 2 specific components, one Cassandra and the second Spark Streaming. So I'm going to go through our GitHub repository and talk a little bit about what I did to explore our data set. So using Cassandra, I first had to create the tables themselves. So in order to do that, I created a script that loaded our data from our 2 tables, the energy and the weather data, into different Cassandra tables. Because the data is just text, there's no images or complex data types, I used a simple strategy, and I arbitrarily decided on a replication factor of 3. Since we don't actually have multiple machines accessing this data at the same time, it's not really a factor that's of concern for us here. So as you can see, I'm dropping the table if it was previously created, and then establishing the columns that I'll be using from the different data sets. I import those and then create a new data set, and then had a select all call to make sure that the table was created correctly. From my understanding, Cassandra tables should be created essentially one per unique query. So in that spirit, that's what I tried to do here. So here you have the table sorted, so it's energy by price, the fossil energy sorted by time. As far as weather goes, you've got the weather sorted by time, and then the temperature by time and city. So if you wanted to query your data by temperature, you'd use this table. If you wanted to query it by time, you'd want to use this table. And then if we hop back over, we can look at the actual queries themselves. So I'm querying each table individually. For example, the fossil energy that's sorted by time, I have a query that says, okay, so if there is no hard coal, no energy produced from hard coal, then we want to go ahead and return those entities. In a similar way, I also am querying the weather by time, where it has the temperature, return entities where the temperature is greater than 270. Pretty basic, pretty standard queries here. And then if we go back to our results folder, this is where the results are. I have a couple of screenshots of these results. So this has, of course, the date, temperature, the city name, querying the weather data set. And then in a similar way, we have the results from another query from our weather data set. Now, while this is interesting and the process was interesting to go about, our group decided that, again, because we don't have multiple machines querying this data set, Cassandra wasn't really going to be something that we were going to focus on. So after this basic implementation, we decided to move on to other tech stacks. So I will take you to the other component that I worked on, which was Spark Streaming. So with the Spark Streaming, I did this in 3 different components here. So the very first one is the REST API using a Jupyter notebook. So I was able to find the same API service that Kaggle had used to populate our original data set. Unfortunately, due to a paywall, I was only able to use the API service that returned the current weather. I really wanted to do a call that would retrieve weather for, say, 2 weeks, which would be easier and more interesting to query. Say, what was the date with the highest temperature? Give me the the 7 days that had the least amount of pressure and be able to analyze it that way. But however, I was still able to come up with a few workarounds. So for this very first one, it's the REST API to Spark data frame, single call, and then save portions. So the single call is just making one single call to the API service and then essentially saving that information that's returned. So while it did successfully retrieve the JSON from the API call, which then converted it to an RDD and then to a Spark data file, the complex data types of the Spark data frame made it kind of impossible to conveniently save the data to a CSV file. So as you can see here, here's where we're making the call. Here is the output of that response, which definitely has useful information, but the format isn't what we want to be able to query it easily. And as you can see here, when it's converted to a Spark RDD, the nested nature of the JSON made it really difficult to easily convert it to a data frame. So as you can see here, the main class has several different elements that I'll show later, but it wasn't easily changing into a data frame. So I tried a couple of other different things to select certain elements from the JSON and then save it into a folder, which I was able to do. And then we've got the current weather, which has all of the columns saved. And then I also attempted to isolate specific elements of the JSON, which I was able to get the nested elements, but I wasn't able to concatenate them. The results that I was getting weren't particularly helpful, so I attempted to do something else instead. Let's see here. So the one that I found the most useful is in this JSON to CSV Jupyter notebook. And this is the one that I think is the most useful and I would say most proud of for this. So setting up a Spark session and using the Spark context, I was able to create a function that created an API call for each city that you pass to it. And then after querying the API, saved those results into a Spark data frame and then modifying those data types so then it could be saved as a CSV file, expanding the nested elements, and then compiling all those elements together into one data frame. I was able to get the final result of one single data frame that had weather or the current weather for our 5 different cities in question. And then I was able to save that to a CSV file. So potentially you could use this for any city. You could potentially run this, say, once every half hour and be able to get updated information that we could then incorporate into our existing data set. Finally, I explored Spark streaming with the same API. Now, because our data isn't streaming like, say, like an Internet of Things device where you have a constant stream of information, this API service operates more on a discrete GET call. So I attempted to kind of create a mock stream of information so I could explore the potential use of Spark streaming. So of course, after setting up Spark, creating a context, creating a function where I could actually call the API service. I created an object that I called an RDD queue and loaded several different calls to the API into that object. So as you can see here, we're going to call it 6 times. We're going to give it an interval of 10 seconds, which of course could be modified to, an hour, 24 hours, whatever. So I loaded, I believe, let's see here, 6 measurements into this object. And then I processed the stream using a dstream. And then I did 2 things with those. I first saved it as a text file where each batch, which came at an interval of 1 second, each batch would be saved to its own output folder. The format that it was in, it wasn't even as nice as this. It's kind of a jumble of text where it's still legible, but not really usable, not easily analyzable by say like a Spark data frame or a Pandas data frame. And then also used for each RDD to process it and display it out to the display right here. So interesting, definitely potential there, but not really in its current state relevant or usable for our data set. Hopefully in the future, I'd really like to use the JSON to CSV to be able to load information to a machine learning algorithm. But I think as of now, it's incredibly helpful to have access to new information.